Now, what you see here, of course, it's a GIS, you know the interface already. We have many groups and many layers. First of all, I would suggest that you can do like I do. You can just load it and shut down everything. Yeah. And if you have an issue, you can also share your screen. But first of all, try to load this from scratch.
Okay.
Now you see it says unknown CRS. This is not a big problem, but in fact, it's called Mars sinusoidal central longitude sphere. That's essentially our CRS. There are some issues here and there, but this should not be a problem. Now, I define it, but that's not a big deal because anyway, the data, they have been all made at the very same, with the very same coordinate system. Could you follow so far, or is your project having any issue?
No, no problem.
Doing fine for me.
Now, let me just see. I have to ask a person. I have to add the person.
Sorry.
Okay. Now, you see here, if I turn on the global geological context, I have some kind of units, which are actually vector data. And then I have different layers. I have some contacts, which are just contacts. I do have some polygons, and you can see easily what these polygons are with this querying. Here there is a label. This just is exactly what I was showing before. More or less, it tells you the age of the deposits. And there are on top some structures. This is some global map, which is definitely not at the scale of what we need. But if we zoom in, then we start having, this is a color-coded cherry relief. So it means that this here is just topography. Yellow is high, blue is low. And I think our crater is this one. If I make a profile here, you see, more or less, I'm going from 1,000 meters to minus 3,000. And our actual crater is at about, it starts at about minus 1,000 meters and goes up to minus 3,000. So it's basically a 2-kilometer deep crater. And how big it is, essentially, this is can be measured. And we have to do it in Cartesian. Yeah, 50 kilometers. In total, it's about 60, 70 kilometers. So in any case, this is like where we are. On top of the topography, which is very coarse and very rough, we do have a bit high resolution images. Now, you remember, go ahead, please.
Can I ask you a question right now?
Yeah, sure.
I did not see how you opened the tool to see the profile, which is
I show you, look, can you see my screen now? I'm in plugins. It should be installed by default, but in case you look for it, it's called profile. Installed, profile tool. I think it's also installed on your GIS by default. It's this icon. And you should find it under profile tool if it's installed. Can you? It's handy. We don't use it so much during the activity, but it's handy.
Thank you very much. I'm installing it. Thank you. Sorry.
Yes, so it's not by default, sorry. So feel free and install it. It's actually quite handy. Once, tell me if you want me to move on.
Yes, yes, yes. Thank you very much.
Okay, now if we turn on, if you look here, you have something that looks like optical imagery. In fact, it's not visible, it's thermal, so it's not visible images, but it's daytime thermal images. This already starts to look a bit like an image of the surface. So while this was topography, this is an image. And this is essentially how much is the thermal emission during the day. And that's the very same thing during the night. Now, this is something that at the moment we are not using so much, but it can be very handy to distinguish different lithologies, because obviously if you're going to the beach and you go there during the day, it's very hot. If you walk on the beach without shoes in the night, it's actually very cold. And maybe if you have some concrete, like a path going to the beach or a rock, in the evening, while the sand is cold, also the concrete or the rock can be still hot, or at least warm. And that's exactly one of the things that can be done with thermal imagery to try and distinguish between loose deposits like sand and rocky or more solid material. One of the key data sets is, again, it's based on thermal imageries, is the thermal inertia, which essentially tells how much things are keeping the heat or releasing it fast. And typically rocks, I say, they keep it very long, and sediments like sands or fine-grained material that is loose can get cold faster. Which means that if during the night I take a picture with thermal wavelengths of something, and this something is very bright, means that it's still hot, relatively speaking. And if it's dark, it means that it's cold. So if it's cold, probably it's loose deposits, and if it's hot, it's probably more rocky or more solid. And this we keep it in mind. Then we have HRSC. HRSC is a camera that takes pictures in colors, you see. That's a bit stretch. Then takes picture in black and white. And the good thing of HRSC, it also takes stereo images. So it can make a topographic model, like Ricardo was mentioning, out of this data. Now, what we will be using mostly is CTX to map, and we have handy also some contours. We don't use them really for mapping, but they're useful so you have an idea which is the delta of the topography. The same profile, you can use it also with the topography. For example, if I click on the layer on the left and I try to trace a profile, and then I add the layer, you see that this is much more detailed compared to the MOLA. I can change the color. The MOLA is blue, and this is red. You see, they are very consistent because they are co-registered, but they are different because on the MOLA, which is low resolution, you miss many details. So you miss the central peak here, for example. But all in all, they are very comparable. Now, when it comes to CTX, we do have essentially our base map that we will be using, and the idea is to try and make a map that cover this basin, try to distinguish the areas. Now, first of all, let's have a look at the units that I was showing on the presentation. Here, there is the rim of the crater. You see that it's actually relatively sharp, but in some areas it's less sharp. And outside the rim, there is some areas that has kind of a very complex textures. There are also other craters. These are probably part of the ejecta of the crater. Now, the reason why this crater doesn't really look like a fried egg in the pan is that this crater is not so fresh that you can see exactly the ejecta. The ejecta around are probably they've been eroded away, they've been covered, they've been also modified by other craters, and so on and so forth. On top of it, you have the rim, the inner rim, which includes some kind of parts of bedrock. So this is probably rock that has been not only slumped, but also collapsing on the flank of the crater. Can you see my camera?
Yes.
Okay.
Yes, we can.
Yeah, well, I mean, it doesn't add much to that. So essentially, these are parts of the inner rim that collapse. One can choose or choose not to map them as individual units, because at the end of the day, it's the same material, but structurally they're different because one is more or less in place, a bit uplifted, and one has been downwarped quite a lot. If you use the hand, like in any graphic software, you can pan. And if you use the wheel of the mouse or the trackpad, you can zoom in and out. Probably using the hand is very handy. Then we have, as we mentioned, a central peak, or actually a central uplift area is not an individual peak. And it's, if you look in detail, it's created by small hills. The limit between the central peak and the crater floor is not so clear, so one can probably use some limit that maybe symbolizes something not super clear. And then there is between the rim and the floor, there is sometimes these materials here. If you remember the talk of Monica of the fans and the apron, you have a kind of a channel here, and then you have this kind of fan shape distributory system, and you have another one here. So it may be that actually these are actually fans producing an apron, and you see that also there is some kind of pattern of erosion here. So in between this and the floor, one probably could try and put a limit. If it's so sharp, it's not clear, but one could try. Also, I was mentioning this kind of terraced unit. You see here, these kind of deposits here, they're abruptly ending here. This probably tells a story. I mean, this is a crater that was clearly forming after the impact that produced the big basin. This crater originally had the rim that was probably sharp, but it seems like it's filled with material, whatever it is, we don't know it really. And a part of it is eroded. It's like, imagine that you are on a badlands. These things, in Italian, we call it calanchi. You know, the badlands on materials that are like not so consolidated or not so solid, they can be easily eroded, and they form this kind of pattern. This, of course, seems like an edge that typically it's going backwards. So the more erosion is occurring, the more this is being eating away until it's eroded away. That's on Earth. Of course, here we are talking about things that probably stopped in terms of active erosional processes, fluvial or alluvial. But at some point in time, this edge was probably closer to one of the rim, and then it degraded more and more. I'm not saying that this is active now, but at some point in the past, that can be also billions of years ago or hundreds of millions, this was active. You also have some other channel that is cutting through, and probably there may be some kind of fan deposits here at the edge of the crater. Here also, you see that there is this kind of sharp channels, some kind of erosional patterns, and some features that are suggesting to be channels here. So this also can be aprons. In terms of topography, we can try to see if this actually shows up. And you see, so here we are in the inner rim. This is more or less the terrace with some material. There's some inner block that was collapsing. Then you have the slope, and then you have this slope that goes down. So this is not flat, in fact. This is dipping. And this dipping can tell you that probably this is kind of the material, probably talus, later on that is covering the floor, which means that imagine that you're doing a cross section of it. Can you see my mouse? Possibly the crater floor was below here, and there is like, I don't know, a few hundred meters of several tens of meters of material that have been filled, and they're kind of pinching out towards the end. Then we got this feature here, which is very prominent. And if you look in detail, you see that it's not only one. There seems to be an upper lobe, a middle one. There seems to be something that are looking like ridges. They can be layers. They can be shorelines. It's not clear. But definitely there is some kind of bidimensional pattern. There is this kind of concentric-like pattern that can be more or less associated with the sharp scarp, like here, here, and here, or just with these features. We don't have to interpret so much, but that's a data point. On top of it, here you can see that this unit is filling some older crater. So here, for example, if, for example, you map this unit, you can put the limit here. But maybe there are also lower parts of the same fan-shaped deposits here below. So one could draw them. And probably the easiest thing is to use mapping, which we do in a moment. Then we have this, you remember I was showing before this kind of dark materials. If you look in detail, this dark material, first of all, you see that there is some issue with the image. Now, this is the limit of the data and the fact that I didn't have so much time. But basically, this can be fixed in some way, but for our purposes, it's perfectly fine. This is a non-controlled mosaic. I put some resources on that in the presentation, some links, but we can live with it. And this, it's the dark unit, which is funny because it has a kind of a sharp edge. And it has some crater here. Now, whether these crater are after the emplacement or are just materials that this unit was covering, and then these materials were eroded away, that's another story. At this, remember the scale here, we had 1 to 45K. If you go to 150K, that's it. If you go to 100K, that's it. So we don't have to map this in a super high detail, okay? If we want to have the entire basin mapped. So now you have the MAPI contacts, units, and the linear feature here. And if you have any question, please stop me anytime. Otherwise, I will suggest that we can start playing a bit and try to look at the contacts. As we said, some contacts are easy. Sorry. Here, this contacts is very easy. This is probably easy too. Here, we can kind of find a contact around where maybe we can name it as a uncertain or certain. Here also you have these talus deposits that probably you can have a contact here, and these units here that can be relatively good traced. Can you see my screen if I have to change my app? I don't dare to change my app because it works. Can you please open the PDF of the talk of this morning? If you don't mind.
Yeah.
Can you please go to page 43?
Geologic cross-section.
Exactly. So more or less, if you want to do it again, we don't want to do it, but I could just mimic it. We went, sorry, okay. We went from here roughly to here, and then something like here. So more or less, that's the same profile that Monica was showing. And it looks very similar, you see? Well, here we got another hill. Actually, it's the rim of the crater. So basically, the units that are here are somewhat like the drawing of Monica. If we move to the next one, slide instead 44, this is essentially a very, very rough way to see it. But we have the ejecta that are outside, the rim itself, the inner rim with the listric blocks. That it's interesting because you find this kind of hills, this kind of mountain range inside only here and here. And here you see them less, probably because they have been covered. So here you can see that there is less mantling material on the southeast, while to the north, you see that actually there is this kind of smooth materials that are filling in that more or less are kind of leveling the top. The same here, isn't it? So this will be, of course, we don't expect precise and symmetry, but we will expect this structure to be relatively symmetric. On top of it, as I said before, the central peak area, it's quite modified, eroded. Now, something that we can already say here is that this black unit, it's on top of something, right? Does it seem clear to you from the images?
Yes.
Okay, cool. Now, my second question after this kind of overview of the units cropping out, do you have installed mapping or do you need help with that?
I have installed it.
Everyone has it?
Yeah.
Yeah.
Okay. Very good. Did you install also the symbology?
Yes.
Yes.
Perfect.
Yes.
So more or less with that, I think we can actually start and try to play around with the contacts. One thing is that Mappy doesn't care if we write the contacts in multiple lines as long as they are crossing, and they also don't have to have an attribute. But if, for example, we have a unit that on one side has a sharp contact, on the other side has not, if we want to distinguish them with symbology, we may want to use different lines. For example, let me make a dummy thing, yeah? Okay, I can create I can start editing. By the way Mappy works is that, of course, the point are giving the attributes and the contacts are what you describe. If you go to the properties, to the attribute table, you see that there is a feature ID and the contact type. We have this contact type because then we can say contact type certain, uncertain, sharp, gradational. The units, they have something more. We have GeoUnits, which is a name. We can add more. So if we want, we can add also something like nodes. You just have
we
to
don't
go.
see it.
You don't see it? You know why?
We
Because
don't see the pop-up. We don't see.
because the pop. You are right. Because the pop-up is a different
because
window.
Probably you share the software and not the screen.
Yes. Now let's be brave. Let's try to share the screen again, and let's cross our fingers. Can you see it?
Yes.
Yes.
We did it.
Okay. Now I do it again. Contacts, open attribute table, contact type, units, open attribute table, GeoUnits. And of course, linear features, they also have it. Linear type and nodes. For example, here I added nodes, but you will see you can do it yourself. So let's start to trace some contacts, and we can start together, and then you can move on with yours. I mean, this is a good one because it's an easy one, and also we can also choose the scale, because if you're doing it 1 to 10,000, you see, we can click forever. So we have to actually, zooming is good to have a look, but when we're mapping, it's probably good to have a uniform scale. If we want to be fast, we try 100K, and maybe if we cannot see something, we can zoom a bit in. Do you agree with me? Or if you want, you can also choose other scales.
Yeah, it's fine.
Okay, so you can just toggle editing. And once you have it, of course, you can have add length feature, and of course, you can then modify it. For example, now don't look how little detail I'm putting on it. It will be good to cross. And then if you right click, the feature ID, it will be auto-generated. It's typically sequential, 1, 2, 3, 4. And the contact time, we call it certain, okay, or sharp. Now let's see if it's crossing. Okay, it's crossing. This should work. Now let's make a test. Now let's assume that all the things around is another unit. So we can create a new unit, a new contact, for example, the contact with the base. Now I'm doing it very sloppy, but please do it nicer than I do. Okay? Imagine that I'm outlining the floor and something else, and then we discuss it. Now assume that I'm trying to get a limit here. Okay, this is just to make it work once. Okay, this is not really nice, but just roughly I'm trying, and then I try to let it intersect. And this I call it floor. Okay, sorry, this is the contact, which is kind of
Uncertain.
well, yes. This is actually, I can put uncertain, but is wrong, because in this case I put uncertain, but here it's quite certain. Here is a bit less certain. So what I should have done is actually to split it into the part that is certain and the part that is uncertain. So if you want to do it properly, you should split the certain by the uncertain. But here I wanted to check something else. Now I have two contacts, but I don't know the name of the units. We say that we had a crater floor, and we say that we had a dark unit, okay? Now to do this, I can just add Mars units, and I just add a point. I add a point, for example, this is, I call them dark deposits. Look, I'm using the underscore because I always prefer to have a very compact name without space, but you can use whatever as long as it's consistent. Okay. And then I can call this with a new, wait, save. I stop editing. I start editing again, and then I add another point. I call this crater floor. One second. Okay, now we got 2 points. If you want to see them better, because I didn't do it properly, I mean, the color is not great. You can change the color. You can change the size. Okay, that's too much. Okay, you can apply. Oops. So now, also our contacts, they have a weird color. Let's make it more visible. We also want it to be, oh gosh, that's too much, but that's okay. And we can do it 1. You see? Now my units are definitely too big, so I make it 4. By now, you know this very well from the other practical. So in this case, I started outlining this unit and this floor. It's still indifferentiated. Now we see that we can add units. That's the nice thing of MAPI, because you don't have to worry that now there are further units. We can look at them further on. Now, if I look on the toolbox, which I don't want to be here, I want to be here, and I look for MAPI, please stop me anytime. Huh? We can try and construct a map. Shall we try?
Yeah.
So now with the map construction of MAPI, you need some input lines. In this case, we have you see there is a lot of layers, but what is ours is the contacts, okay? If we use the wrong layer, we just will have some mess, but we will recognize it. So the contacts and the points, we call them units. So since there is only 1 point topology, there is no choice. But here we can get confused, so we should be careful on that. Now we extend the distance, we can put 50 meters just in case, but we crossed, so this should not be much of a deal. And we can save to a file, okay? And we can put it on downloads. We can put it on Mars hands-on. I can make a directory and I call it mappy stuff, but you can put it wherever you like, actually in vector. And we call it mappy tiras. You can really call it the way you like it. Oops. Okay. Why did I like it? Mappy tiras. Okay, I can run it. Input lines, I have to tell it. Run. Did it complain? Wait. Let's try again. No special index, but that's okay.
Angelo?
See, Luca.
It's very likely because you didn't save and stop at editing the layer.
Sorry, I didn't stop editing
Yeah,
of the linear. You're right. Yes, sorry. I was still editing. Thank you, Luca. You're a savior. Of course, I should have saved. I saved only the other one. Let me remove it. Oh, no, I didn't save the other one either. So please save both of them. Now we can start again with the linear, sorry, the contacts and the units. We extend, although it should not be needed. And let's save it to a first file. So this is map tiras. Let's call it version 01 because it's rough. And then we can also see how the mapping evolution runs. Okay. Now this looks better. Now we have the polygons that inherited the geometry from the contacts, but they inherited the name from the units. We can also change the symbology of it. We can go from single symbol to categorize. We can classify based on GeoUnits. And the all other values, we can actually, we can remove it because we don't have everything as a value. And we have crater floor vanilla. We can make it of another color, like, oops, dark. And well, maybe a bit less dark. And the delta hypothesis, we can make them very dark because they're dark, okay? We can add some transparency to it. And, oops. %. And, sorry, to this 50%.
I think it's under legend.
Yeah, well, you can do it via the legend or via here. It's the same, sorry. So basically, you can change either from the legend or from the properties, but you have to go into layer rendering, okay? So now we have 2 units. We want to continue, so we can essentially keep our products, which will be evolving off, and we can continue with the units themselves. For example, this is an easy one, so we can do it. We can toggle editing here on the contacts. We can create a polyline. And that's an easy one. And then we can symbolize it accordingly. So it's a crater. Again, the more you zoom in, the better you can do this. But for our purposes, it should be enough. Contact type, I think this is actually pretty certain, okay? Now we save, so we don't incur in the same problem. We have to give it a name. So we go to the units, we start naming, and we can call it small crater. Well, it's not too small, but still it's smaller than the scale of the basin. But you can call it just crater or impact crater. Remember that you can also change the label, so that's not the problem. Now, if we do this, and if, for example, we start also, sorry, let me stop. No, cancel. Let me stop editing and save. Now we have a new unit. Mappy doesn't know it yet. Now we can move on, and we can start highlighting this other dark unit. Please feel free to stop me anytime. We have to go on contact, sorry, so units has to be closed. We open contacts and we start digitizing this. You can do it in a much more fancy way if you have graphic tablets or if you're using advanced tools, freehand. But for the scale, now we are 1 to 87K. So we're a bit too much detail. We can try, you see, this is a problem of scale. For example, if I'm mapping a 100K, should I do this? Or should I just do the one below and keep this island separate? This is actually a proper problem. So since now I'm a bit lazy, I put it together. But if I map at 30, 40K and not 100K, I may want to keep this as a separate unit and then just do this, okay? So depending of, oops, I lost it. Depending on what you're mapping, what scale you're mapping at, you may want to use more or less detail. So this is what in vector terms is called generalization. So in this case, we do a heavy generalization of the unit. Here is it crater floor? Well, I give my luck and I try to go this way. And it seems to me that this unit is going here. And I have the feeling that this unit here is stopping here. Okay. And this, how do we call them? Dark deposits. Now, imagine that I call them just dark because I mess it up. I can homogenize the nomenclature. First of all, let me stop and save. And then I go to the contacts. Oops. I did a mistake. And you know, what mistake did I do here? Can you tell it to me? Because I did a mistake. I called the unit, the contact with an attribute of the unit. So I have to do this and to have to fix it, okay? So we all make mistake and we all can fix it. So now this is a certain contact and what is missing is the unit. Now, I was unsure about the name that I use. The best thing is to write it on another document, like crater floor dark deposits, because this is actually our legend, essentially this guy. So you choose your own units. For example, I put my notes here and I call like units, contacts. I have certain, uncertain, and for the contacts, and for the units, I have, how did I call them? Crater underscore floor, dash deposits, impact crater. Crater floor, dark deposits, impact crater. Now, if I work on a text file, the good thing is that I can put it on Mars, like units.md. I can actually put them in stratigraphic order the way I want it. For example, if impact crater comes on top. And again, you don't have to do it like that, but this could be an easy way for you to try and work out what is the relatively age, because it's easy, it's a text file or Word, whatever you're using, and you can move things up and down. Now, we need to give an attribute here. We add it, and sorry, we add it somewhere in the middle, and we call it dark deposits. Okay. We save. Now our map is evolving. Our product from map is not yet evolved. I will say that we move on. And for example, here, I put this fun shape deposit inside the floor. Of course, that's not okay. Now, I don't have to do everything from scratch. The good thing is that what I can do is that I can go to the contacts. I can edit. I just have to actually put a line. And are we certain of this or not? Any suggestion?
I would be uncertain.
I also will be uncertain. I think it's a good point, because here it's not clear whether this is actually continuing a bit into the floor on the apron, but let's put uncertain to be safe. Now we have, well, let me first stop, sorry. Now, we only need to miss one thing here, which is an attribute, which means that we have to start the units and add the attribute here. How do we want to call it?
Uncertain.
No, that's the unit name.
Fun is okay.
Fun shaped deposits or fun. Okay.